Your solutions to homework set number 3 for ECE 341. This homework set we're looking at combinatorics with a game of Farkle. In the game of Farkle, you toss 6 dice and different combinations score different points. So the first problem, what is the chance of tossing 6 dice and winding up with 2 triples? So like 3 1s and 3 2s. Well, we know from enumeration the answer is 300. So how do you get that? Well, the trick is if I have 2 numbers with the same frequency, I do their 6 numbers, choose 2. That picks 2 numbers for x and y. For the x's, there are 6 spots, pick 3 of them for x. There are 3 remaining spots for y, pick 3 of them for y. Multiply it all out, I get 300. The right answer. Problem 2, chance of getting a 2 pair. So here I've got 2 x's, 2 y's, and single, a and b. So these can't match, otherwise it'd be a different number, 3 doubles. Since x and y have the same frequency, it is 6 numbers, choose 2 for x and y. There are 6 spots for x, choose 2. There are 4 remaining spots for y, choose 2. Now for a and b, 2 numbers are used up, there's only 4 left. 4 numbers for a and b, well, 2 ways. 4, 2, choose 2, and then 2 spots for a, choose 1. That's one way to do it. Or there are 4 numbers remaining, pick 1 for a, 3 numbers remaining, pick 1 for b. Either way gives you the same answer. Answer is 16,200. Part C. I've got 3 pairs. So since these are all the same frequency, it's 6 numbers, choose 3 for x, y, and z. 6 spots for x, choose 2. 4 remaining spots for y, choose 2. 2 remaining spots for z, choose 2. Multiply it all out, I get 1800. Problem 4 is check. In MATLAB, what I can do is enumeration. Enumeration I like because it gives you the right answer. Monte Carlo gets you close, enumeration's dead on. And MATLAB's fast enough I can grind through every possible die roll. So here's all my nested for loops going through every combination of 6 six-sided dice. For each combination, count how many 1s, how many 2s, how many 3s. Sort in descending order. If the highest frequency is a 3, the next highest frequency is a 3, that's 2 triples. If the highest frequency is a 2, next highest is a 2, and the next highest is a 2, that's 3 doubles. And 2, 2, 1 gives you a single double. Run this puppy. Marks get set go. And in 0.966 seconds it gives you the answer. Same thing we calculated. Let's see. Problem number 5. 5 is a z-transform. We'll be doing z-transforms for the next couple lectures. That's for discrete probability events. Now what the z-transform means is if I have this function right here, I can convert back to a function in k. K would be like 1 die roll, 2 die rolls, 3 die rolls, integer values. To do that, what I do is the trick in z-transforms, pull out a z. I'm going to need that later. Now do partial fraction expansion. To find the first term, well, backing up. I know that the answer is going to be something over z minus 0.99, something over z minus 0.96, something over z minus 0.95. To find those somethings, do the cover-up method. If I cover up this guy right here, analyze at z equals 0.99, I get 3.3. To get the second number, using the cover-up method, I cover up the z minus 0.96, analyze at z equals 0.96, and I get minus 12.8. For the third number, I cover up 0.95, analyze at z equals 0.95, and I get 9.5. That's the third number. And the reason that works is these two are identical. Equals is really powerful. That means the same everywhere. At z equals 0.99, this term blows up. These don't matter. So this has to blow up at the same rate. So when I cover up 0.99, this number has to match that number. It goes to infinity with a scalar of 3.3. So anyway, back with the problem. Once you get in this form, multiply through by z. Now these are in my table of z transforms. This is 3.3 times 0.99 to the k, minus 12.8 times 0.96 to the k, plus 9.5 times 0.95 to the k for k positive. Problem 6. Same idea. I've got three terms. I'll pull out a z, and I'm going to have a z minus 1, z minus 0.99, z minus 0.96. Do partial fraction expansion, and for this term, cover up the z minus 1, analyze as equals 1, and I get 10. Repeat for the other three. Multiply through by z. Now these are my table. This is just 10 times 1 to the k, minus 13.2, 0.99 to the k, 0.96, 3.2 times 0.96 to the k for k positive. Finally, with z transforms, I can do time value of money. If I buy a Volkswagen ID4 for $49,000, I take out a 60-month loan at 7.66% interest. What are my monthly payments? Well, this is the equation. Next month, my loan is going to be the current month's loan plus this interest rate over 12, that's my monthly interest rate, times the current loan amount, minus my monthly payments. I start paying every month after the first month. So that's the k minus 1. I don't pay right away. I wait a month, then my first payment comes due. Plus my loan amount at k equals 0. That's a delta function. I only borrow the money once, which is your delta function. Take the z transform. This is the next value of x. That's just x. This is a unit step delayed by 1. That's actually z over z minus 1. That's a unit step delayed by 1. So the 1 over z cancels, and I get 1 over 1 minus z. And the z transform of a delta is just 1. Now solve for x. Bring the x's left, divide through, do partial fraction expansion. This is not in the form that I'm used to. I need a z in the numerator, so multiply both sides by z. Now take the inverse z transform, divide by z, that's delayed by 1, so k goes to k minus 1. And here's your equation. That's how much I owe at month k. Well, in 60 payments, I didn't do that right. If I have 60 payments, that's going to be 61. At month number 61, my loan will be 0, meaning my car loan is paid off. I thought I fixed this. Oh, it's supposed to be 61. When you do 61, I wind up with $994 per month by payments. If I do 60, that means I actually had 59 payments. At month 60, my loan is 0, so I owe nothing. For 59 payments, it's 1,008. I'll take either answer. So that's actually 59 payments is 1,008. But that's homework set number 3 for 341.